Welcome, leaders and innovators. Today we are tackling one of the most critical elements of enterprise AI adoption, grounding. We will explore how to identify the strict business requirements needed to connect generative AI securely to your proprietary data. Let's get started. Welcome to our deep dive on AI grounding. Generative AI is incredibly powerful, but out of the box, it lacks the specific context of your business. As our first bullet points out, grounding is the process of connecting AI responses to your authoritative, real-time enterprise data. Why is identifying requirements for this so critical? Because without grounding, AI can produce convincing, but entirely incorrect information. In the enterprise, inaccurate outputs lead to poor decisions, massive compliance risks, and an immediate loss of trust. Before adopting AI, a business must clearly define what data sources act as the absolute truth. You are not just buying a chat interface, you are building a secure bridge to your intellectual property. Take a look at this decision flow on your screen. It beautifully illustrates the risk and reward of grounding. On the top path, an ungrounded user prompt goes straight to the language model, risking a generic or fabricated response. But follow the bottom path. When a prompt is grounded, the system actively searches your enterprise data first. It retrieves verified facts, combines them with the prompt, and generates a highly accurate, cited response. Identifying the business requirements to enable that bottom path is what we will master today. To identify our business requirements, we must first understand the mechanics of how grounding actually works. The industry standard is a pattern called retrieval augmented generation, or RAG. Look at the how section. RAG operates in 3 rapid steps. First, it retrieves grounding data based on the user's prompt. Second, it augments the prompt with that precise data. Third, it uses the language model to generate a grounded response. As a leader, your core business requirement is defining the scope of that first step, retrieval. Which repositories are considered authoritative, which ones are outdated? You must define these boundaries clearly, or the RAG process will retrieve irrelevant data, defeating the purpose of the architecture. This sequence diagram maps the exact second-by-second execution of a RAG-based grounding process. Notice how the orchestrator sits in the middle. When the user submits a prompt, the orchestrator does not immediately ask the AI for an answer. Instead, Step 2 shows it querying your enterprise data. Only after the trusted data is returned in Step 3 does the orchestrator bundle it with the user's prompt and send it to the large language model in Step 4. Your business requirements dictate exactly how secure and fast Step 2 and 3 need to be. Understanding this flow is essential for scoping your project. Our first major business requirement is absolute data quality. Trustworthy AI does not happen by accident. It depends heavily on high-quality data. If the data you use to ground your AI is incomplete, outdated, or inaccurate, the results generated will be inherently misleading. A fundamental requirement is undertaking a data readiness initiative before deploying AI. How do we do this? As outlined in our bullets, we must break down data silos, clean and deduplicate the information, and create semantic models so the data is understandable across teams. Do not try to boil the ocean. A best practice is to mandate that your team start with the top data domains like customer or product data that unlock the most critical use cases first. This mind map breaks down the data readiness requirement into actionable pillars. You can see the core activities required: cleaning and deduplicating data, breaking down organizational silos, and building semantic models. On the bottom right, we identify the authoritative sources. Your business requirement documentation must explicitly list these sources, whether it's customer CRM data, technical product specifications, or internal HR policy documents. If a document isn't officially designated as authoritative in this map, the AI should not be allowed to use it for grounding. Quality control at this stage prevents failure downstream. Requirement number 2 is security and access controls. High-quality data is useless if it falls into the wrong hands. If security controls are weak, sensitive enterprise information can be exposed, creating massive compliance and reputational risks. When we ground AI, we must implement identity-based authentication. This ensures that when a specific user asks a question, the agent only surfaces content that the specific user has legal permission to access. How do we guarantee this? In Microsoft environments, this is handled via the Microsoft Graph, which respects your existing tenant permissions and encrypts all data in transit. Your business requirements must explicitly state that any grounding solution implemented must strictly inherit and obey your existing role-based access controls. Let's follow the security architecture in this flowchart. A user request comes in and immediately hits the identity and authentication gate. If unverified, access is denied. If verified, the system moves to check the specific user permissions. The critical node is here, access allowed data only. The grounding mechanism must be restricted by this boundary. It only pulls documents that the user could manually open themselves. Finally, that secure, filtered data is used to ground the AI prompt. This visual proves to your security officers that adopting generative AI does not mean bypassing your established enterprise security perimeter. Our third requirement is compliance and auditability. This is especially critical for regulated industries such as finance, healthcare, and legal services. The business requirement here is simple but rigorous. The AI must provide verifiable proof of its answers. Why? Because grounding reduces the risk of non-compliance by ensuring decisions are based on verified information. To meet this requirement, your grounded AI solutions must generate citations and links pointing directly back to the original source material. Furthermore, a deep dive into compliance requires transparency. The system must inform users that the response was generated by AI and provide a clear audit trail of the references consulted. Trust is earned through transparency. This diagram showcases the compliance lifecycle of a single AI response. Once the grounded AI response is formulated, it immediately triggers citation generation. These citations provide a direct link to the source document. This is where human oversight comes in, the user verification node. By allowing the human to easily click and read the source document, we maintain a human-in-the-loop architecture. Ultimately, this seamless chain of evidence leads directly to regulatory compliance. When auditors ask how an AI made a decision, this workflow provides the exact document and paragraph used. Requirement 4 focuses on connectivity and architecture. You have clean data and strict security, but how do you actually wire it to the AI? You must identify exactly where your required data lives, whether it's in SharePoint, Dataverse, or external third-party systems. Your business requirement documentation must define the integration strategy. Will you use Copilot connectors, which index the data into Microsoft Graph for broad Q&A, or, as the deep dive explains, will you use Power Platform connectors to fetch live, real-time data from external APIs without actually copying that data into your tenant? The choice between index then answer and real-time retrieval drastically impacts your project's architecture, cost, and latency. Look at this architectural decision tree. When planning your grounding connectivity, the first question is data location. If your data consists of internal documents and files, you route to Copilot connectors and Microsoft Graph, leveraging an index-then-answer model. However, if your requirement is to pull live data from an external billing system or a live support API, you route to Power Platform connectors for real-time retrieval. Defining these connectivity paths up front ensures your engineering team builds the right integration layer for your specific business needs. With our requirements captured, we must now define our execution strategy: build, buy, or extend. This is where business leaders must balance speed, cost, and the need for customization. If your requirement is standard document summarization grounded in secure employee files, you buy an out-of-the-box solution like Microsoft 365 Copilot. If you need to query your proprietary inventory system, you extend Copilot using Copilot Studio. But if you have highly specialized compliance needs or need to orchestrate complex RG pipelines over unique data architectures, you build a custom machine learning solution using Azure AI. The golden rule here: start simple. Use pre-built services first and only invest in custom RG builds when the business case clearly demands deeper customization. This decision matrix perfectly summarizes the build versus buy conversation. Once a business need is identified, you assess the required complexity and control. For standard, fast deployment, you buy Microsoft 365 Copilot, yielding immediate ROI. For connecting a custom data source to everyday chats, you extend via Copilot Studio, unlocking targeted workflow value. For highly specialized, deeply governed enterprise applications, you build using Azure AI RAG architectures, creating true strategic differentiation. This framework ensures you never over-engineer a simple problem, while maintaining the flexibility to build highly complex, grounded solutions when required. To tie all these requirements together, let's look at a powerful real-world use case: automating an IT help desk. The business goal is to provide rapid self-service for employees, drastically reducing ticket volumes and the need for human intervention. To do this safely, The organization builds a Copilot agent grounded directly in their existing knowledge articles hosted in ServiceNow. Let's review how they met our 4 requirements. Data quality, they curated their best IT articles. Security, the agent authenticates the employee, ensuring they only see solutions relevant to their role and region. Connectivity, they used a Power Platform connector to fetch live ServiceNow data without duplicating it. And finally, strategy, they extended their existing environment rather than building from scratch. The result is a highly accurate, grounded AI assistant that safely resolves technical issues in seconds. Let's walk through this real-time sequence. The employee asks the Copilot agent how to reset their VPN password. Crucially, the agent does not guess the answer. It immediately authenticates and queries the live ServiceNow knowledge base. ServiceNow returns the officially approved, secure article. The agent translates that into grounded, easy-to-read step-by-step instructions for the employee. Once the employee confirms success, the agent can even log the ticket resolution back into ServiceNow. This is the ultimate promise of grounded AI, secure, accurate, and fully integrated business value.